All right, here we have section 2.3 on real zeros of polynomial functions. One of the ways we can verify that we have zeros is by doing long division of polynomials, which is one of my favorite things to do. So when we are doing polynomial long division, if you remember from Algebra 2, we take the bigger polynomial, which in this case is the 6x cubed minus 19x squared plus 16x minus 4, and put it underneath the division symbol, and you're dividing by x minus 2, so that goes on the outside. Now I'm going to try color coding these steps so that you can follow along with me as I talk slowly. First, we look at the first term on the inside and divide by the outermost term on the outside. If I do 6x cubed and divide it by x, I'm going to get 6x squared, which I'm going to line up with the other squared term inside of the division symbol. Then I'm going to multiply that 6x squared out to both terms on the outside. 6x squared times x is 6x cubed. Those should match. If they don't, you did something wrong. And then we multiply 6x squared by negative 2, which is negative 12x squared. At this point, we are going to change the signs of the two terms and add them down. These first two terms always need to cancel or you did something wrong. And then add the negative 19x squared and the 12x squared. That's negative 7x squared. And then we bring down the next term and start the process over. I'm going to divide the negative 7x squared by the furthest term on the outside, that x. If I divide them, I'm going to get negative 7x and multiply that back through to both terms on the outside to get negative 7x squared and positive 14x. Change the signs and add down. Bring down our last term and do this step one more time. 2x divided by x is going to give us 2, and multiply that back through. Hopefully on that last term everything cancels out, which means we have no remainders, and our answer is the polynomial on top. We will eventually have remainders, and I will show you what to do with that when we get there. All right, do another long division. This one's missing a few terms. This one doesn't have a squared term or an x term, so we actually do have to put those in as placeholders to help us stay organized. But the process is exactly the same. We're going to divide the first term on the inside by the outside most term, which will get me x squared, and then I'm going to multiply that back through. X cubed minus x squared. Change the signs and add down. Divide x squared by x, which gives me x. Multiply that back through. Change the signs and bring down our last term. Last division, x by x will get us 1. Multiply that 1 back through and we get x minus 1, which is good because that means we're not going to have any remainders. And our answer is the top. All right, let's get some better ones. Those were boring. Let's get some more exciting ones up here. I love polynomial long division. It's very procedural, and as soon as you get that procedure down, it's not difficult at all. If you need to slow this down, pause it, redo it to get that procedure down, do what you need to do. All right, so we need to divide the innermost left term, 2x to the fourth, by the outermost term, 2x. If I divide those, I'm going to get x squared, x to the third rather, sorry. Oh, I missed it. Oh, goodness. I was like, that's not right. I am missing the x squared. Whew. Let's try again. The 2x to the fourth divided by 2x squared. That's better. That is 2x squared. Getting concerned. Multiply that 2x squared back through to all three terms on the outside. Becomes 2x to the fourth plus 4x to the third minus 6x squared. And then I change all the signs. X squared, I'm going to bring down the rest of it. Since we're dividing by a three-term polynomial, we need to have three terms when we're ready to divide. So we have x squared divided by x squared, which is 1. Multiply that back through. And change our signs. And x plus 1 is left. Now that is our remainder. I cannot divide x by x squared and get a number. See, I'm all the way to the farthest right here. So that means that whatever I have left is my remainder. So the 2x squared plus 1 is my main answer, and I'm going to add that remainder, x plus 1, divided by the polynomial on the outside. That's how we write our answer when there's a remainder. That was fun. Now, polynomial long division can work for any sort of long division of polynomials. Synthetic division is special when you're only dividing by linear terms, when our divisors are linear, meaning we could not have done this on this question because this was a quadratic. Synthetic, if you remember, this is also relatively review from Algebra 2, we only deal with the coefficients when we do synthetic division. So we have this big box, and across the top row, we're going to put all of the coefficients of the polynomial that we're dividing, making sure that if we miss any, we put zeros in. So the 1 for the x to the fourth, 0 for x cubed, -10 for x squared, -2 for x, and 4 for the constant. Now on the outside, we have not just the 3, but we're actually thinking about what would it be if we set that x plus 3 equal to 0, and we would get -3. That's what goes on the outside. So the process here for synthetic division is that 1 always drops down. The first number always drops down. Don't do anything else with that. Then we take that number, multiply by the -3, which is going to then line up under the 0. We're going to add that column down, 0 plus -3, which is -3. And then we're going to repeat that cycle. We're going to multiply the number on the bottom by the -3, write it underneath our next number in the box, add down, multiply, add down, multiply, add down, and this last spot is our special spot. This is our remainder. So the last one is always the remainder. Now we need to take that from numbers and turn it back into a polynomial answer. So if we took a quartic, a fourth power polynomial, and divided just by linear, that means our answer is going to be 1 power lower. So when I take my coefficients here and turn this back into a polynomial, I just have to think about my starting degree is going to be 1 lower than what I started with. So x cubed minus 3x squared minus x plus 1, and that remainder spot plus 1 over our divisor, x plus 3. Okay. Show that we have these factors of the bigger polynomial and find the rest of the factors. So this last question we did with synthetic division, we had a remainder. So that means x plus 3 is not a factor of this fourth power polynomial. If we do synthetic division with these two factors, in order for them to be factors, we need to get a remainder of 0. So let's start with just the x minus 2, so that means 2 is going to be on the outside. I'm going to put all of the coefficients here from the big polynomial. And I'm looking for a remainder of 0. If I get anything but 0, it is not a factor. First number just comes down, and then we do that cycle of multiplication and addition. Multiply, add, multiply, add. And this last spot is the remainder. So thank goodness that it is a 0. Otherwise, we would have had to start over and try again. So I already proved that the x minus 2 is a factor and broke this down to a third power polynomial. Now, in order for me to find the remaining factors after I'm done here, I want this to be in a quadratic form because I can factor quadratics. I can't necessarily factor a cubic function. So that's why I'm going to use my answer with the -3. I'm not going to go back and start at the beginning because then I would just get broken down to another cubic. So I'm going to keep those numbers in a box for a new step of synthetic division with the -3. 2 comes down and we do the multiplying and adding cycle. And I got a 0, so that's great. It is indeed a factor. Now I'm going to take what's left, that 2x squared plus 5x plus 3, and I need to factor that. Factors of 2x squared are 2x and x. Factors of 3 are 1 and 3. I just have to figure out where those go. In order for us to get 5 as our middle term, that is our setup that we need, 2x plus 3 and x plus 1. Okay, now there's a test called the rational zero test, which narrows down what some options are for zeros of a function, and then we can do synthetic division with those to check whether or not they're actual zeros. So first we're going to take all of the factors of the constant term of our polynomial and divide it by all the factors of our leading coefficient. Make sure we have plus or minus here. It's because we could have negatives or positives. We're going to use trial and error with synthetic division to figure out which ones work, and they work if you get a 0 for your remainder. If they don't work, you try another one on your list. There's usually more than a couple. So for this first example, our constant is the 1, and the leading coefficient is also 1. So for my possible zeros, I'm going to have plus or minus 1. The factors of 1 are just 1, and divided by the factors of the leading coefficient. So here I really only have 2 things to check. I only have plus or minus 1 to check here, which is nice. Let's start with 1. So let's remember we need to have a 0 in the x squared spot. So when I did the synthetic division with 1 as the 0, it did not work. I did not get a remainder of 0, which means I need to then go try -1. This one didn't work either. So that means, since this is called the rational zero test and all of my possible rational zeros, let's add that in there, make sure we know that this is possible rational zeros, that means that there are no rational zeros for this specific example. If none of them work, that means that all of the zeros are irrational. Okay, a couple more examples using that rational zero test. We need the factors of the constant or the factors of the leading coefficient. So the factors of the constant are 1 and 3. Factors of the leading coefficient are 1 and 2. So to list out all of my possible zeros, I'm going to first divide 1 by all my choices, which would give me 1 and 1/2, and then divide 3 by both choices, 3 and 3/2. So technically I have 8 options here that could work. All of those answers positive and all of those negative. So let's start just picking. I'm going to do synthetic division, and if we get a 0 for a remainder, we picked the right one. So to save us time, I am just going to go for the correct answers. You can always graph to get an idea of what the correct answers are, but you still need to go through and do the synthetic division to prove that you got the right answer. So I'm going to use 1, bring the 2 down, 2, 5, -3. Look at that. We got a 0 remainder. So as soon as it gets down to a quadratic form, which this is, it's at 2x squared plus 5x minus 3, that can be factored, or I can do the quadratic formula or whatever you're more comfortable with, and I don't have to do synthetic division anymore. So I'm going to factor this, 2x and x, 3 and 1. So if I set those equal to 0, I obviously picked 1 as one of my answers. When I did synthetic division with 1, I knew that it was an answer. And then I set both of my new factors equal to 0 to get 1/2 and -3. Those are all of the zeros here. Okay. So notice that this question said find all the rational zeros. So we did that. All of our answers were in fact rational. This just says find all the real zeros. So that means there is a potential that some of our answers are not going to be rational, but hopefully that it's down to a quadratic so we can use the quadratic formula to find those irrational zeros. So the first thing we need to do is find all the factors of the constant over the factors of the leading coefficient. Factors of the constant, 1, 2, 3, 4, 6, and 12. Factors of the leading coefficient, 1, 2, 5, and 10. So to list all of our possible rational zeros, we have 1, 1/2, 1/5, 1/10, 2, 2/5. I'm not doing all my repeats, otherwise I would have put 2 over 2 and 2 over 10, just to keep in mind what I'm skipping there. 3, 3/2, 3/5, 3/10, 4, 4/5, 6, 6/5, 12, 12/5. Oh my goodness. So there are a lot of options here, which is why using your calculator to get a good idea of an option to try is a good idea, because we don't want to sit here and be guessing for a half hour. That's not fun at all. So the zero that works to save us some time is 2. And then I'm going to put all my coefficients up here. Bring the 10 down. 20, 10, and great. We got a 0 for our remainder. So 10x squared plus 5x minus 6 is the quadratic that remains from doing that synthetic division. So I'm going to try factoring. You could try that, or knowing that not everything's going to factor, this doesn't look like it would even be an easy factoring problem, I might skip right to the quadratic formula. And I'm going to give you my rounded answers here for the quadratic formula just to save a little bit of time. And we have about 0.5639 and negative 1.0639. And of course we had 2 as well for our 3 zeros. All right, so there's your homework for section 3 for pre-calculus.